Hi Geometry, this is Unit 4 Lesson 2 and it's page 441 in our workbooks. So this is two different problems. They would like us to calculate the values of x and y. So in the first triangle, I noticed that x is the length of the diagonal. So I'd like us to focus in on the fact that half of this, when this diagonal, creates a right triangle. And we know that in right triangles, I can use the Pythagorean theorem, which is a squared plus b squared, these are my two side lengths, equals my c squared, which is my hypotenuse. So in this problem, the side that's x, my diagonal, is across from the 90-degree angle, and it's my hypotenuse. So let's set up the Pythagorean theorem. I'm going to write my x on the left side. That is my hypotenuse squared. That's my c squared. It's by itself, equal to the other two sides, the 4 and the 7. So 4 squared plus 7 squared. Using my PEMDAS, I have to do exponents before addition. So I get my 16 plus 49. When I add them together, I get 65. So now I need to take the square root of both sides to find the value for x. 65 is in simplest radical form. If you try to do the cake method on 65, you'll notice that 2 doesn't go into it, 3 doesn't go into it, but 5 does, and it goes in 13 times. So there's no pairs, no perfect squares. Square root of 65 is an exact answer for the length of this side. If I want to know the approximate length, then I could take the square root of 65 on my calculator and find out it's approximately 8.06. Since I have to truncate around all those decimal points, this is not an exact answer, it's an approximate answer of the length. Let's do the same thing. Pause the video. I'd like you to do the same thing for this right triangle inside of this rectangle. I'd like you to find the value for y, please. Welcome back, students. I hope you got the square root of 260 in your work. The square root of 260 is simplified to 2 times the square root of 65, and I'll talk about that in a moment. And on my calculator, I get approximately 16.12. Again, to simplify the 260, if I start with the fact that 260 is even, then it goes into 260, 2 goes into 260 130 times. That's still even. 2 goes into 130 65 times. We've already discussed that 65 isn't even. It's not divisible by 3. It is divisible by 5. But my 5 and 13 are not a pair. My 2's are. A pair is a perfect square. This pair of 2's come out in front as my 2. That's the square root of 4. And the 5 times 13 stays underneath. So I'd like you to notice that when my side lengths doubled from 4 to 7 to 8 to 14, my diagonal's length also doubled. You can see it both in the square root of 65 and 2 times the square root of 65, and in the 8.06 and 16.12 is double that. So let's take a look at the next page. In activity 2.2. So at the top of page 442, it says decomposing squares. Draw a square with side length 1 centimeter. Estimate the length of the diagonal. So let's do this, ladies and gentlemen. We're going to draw a square with side length 1 and a diagonal, which I don't know, we'll call it x. So I'm going to use the fact that a square is made up of 4 right angles, and my diagonal then just created a right triangle. I can use the Pythagorean theorem on this right triangle with hypotenuse x and sides 1 and 1. So let's write that. A squared plus b squared are my sides, and it's equal to my hypotenuse squared, which in this case is the x. 1 squared is 1, So this is really 1 plus 1, which is 2. And when I take the square root of both sides, the square root of 2 is simplified radical. It doesn't get, I can't break 2 up anymore. So my exact answer is the square root of 2. And if I did it on my calculator, my approximate answer is 1.4. So then let's take a look at number 2. It says measure the side length of a diagonal of several squares. Compute the ratio. So let's just keep increasing my side length and see if we notice a pattern. So I'd like to do 3 squares. If you could do a 2 by 2 square, let's do a slightly bigger square. Let's say it's 3 by 3. And then let's do a slightly bigger square. We'll say it's 4 by 4. Let's see what happens to my diagonal's length. We'll call this X, we'll call this Y, and we'll call this diagonal Z. Let's do the first one together. In my square, this would be my right angle. My hypotenuse is always across from the right angle, so my variable X is my hypotenuse. That's my C. It goes on one side of the equal sign, either side, it doesn't matter. And then the 2 and the 2 go on the other side. I'm going to square them and then add them together. So it looks like X squared equals 4 plus 4, which is 8. And now I'm going to take the square root of both sides. And we've done the square root of 8 before. That's really 4 times 2, and the square root of 4 is 2. I know that that answer is 2 rad 2. So the length of my diagonal is 2 times the square root of 2. Let's do this work again then for my next square. In this case, my diagonal is still my hypotenuse. It's across from my right angle. So that would give me my diagonal's value, y squared equals 3 squared plus 3 squared. Those are my 2 sides of my right triangle. So y equals 9 plus 9. Y equals 8. I'm sorry, that's y squared. Y squared equals 18. Let's take the square root of both sides. We've done the square root of 18 before as well. This is 9 times 2. The square root of 9 is 3. I'll bring that to the outside. That leaves the 2 on the inside. If you need to pause this video to do the cake method on the side, make sure you can simplify this. So at this time, I'd like you to pause the video and I'd like you to find the answer for my 4 by 4 square by yourself. How did you do? Did you come up with the square root of 32 in your work and simplify that to 4 rad 2? If you have any trouble still simplifying radicals, please come to our office hours. So let's make a conjecture. Let's look at our pattern here. Start back at the beginning. When our side lengths were 1, my diagonal was the square root of 2. When my side lengths were 2, my diagonal was 2, square root of 2. When my side lengths were 3, my diagonal was 3, square root of 2. When my side lengths were 4, my diagonal became 4, square root of 2. It appears to me that whatever my side length is, my diagonal is simply square root of 2 times more than that. So if I was doing a 5 by 5 square, I may not have to do all my work. It looks to me like if I have my side lengths were 5, my diagonal would simply be 5 times the square root of 2. So let's look at this as a generalization. This is where we have our 45, 45, 90 rule for triangles. And that's that the hypotenuse equals square root of 2 times the leg. So 45, 45, 90 refers to the degrees of my triangle. In a square, all 4 angles are 90 degrees. So when you draw in your diagonal, you split this 90-degree angle into two parts. So I would have a 45-degree angle and a 45-degree angle when I split my square. So then I have a 45-degree angle at the top, a 45-degree angle, and my third angle is 90. Same thing here. And all four of these, of course, add up to 180 because a triangle always adds up to 180. So this is my 45, 45, 90 rule for triangles. The hypotenuse, which is my longest side, is rad 2 times a leg. Well, the leg is the other two sides of my 45, 45, 90 triangle. So the way you can use this shortcut is if you happen to have 45, 45, 90, I know that this hypotenuse, which I don't know right now, is equal to rad 2 times a leg. My leg is 3. So this is what my rule is telling me to do mathematically. Now, when I see rad 2 times a number, I do simplify that by putting the number in front. It's a little bit like having x times 3. We usually wouldn't write it that way. We would write the 3 in front of the x. The same thing is occurring here. We wouldn't write the square root of 2 in front. So that makes my diagonal 3 times the square root of 2. That's my answer. I'm done. So the same thing occurs here. In this problem, they only tell me the length of one leg. So I need to notice that I have a 45, 45, 90 triangle. This does mean that, first of all, it is isosceles. If it's 45 and 45, then I know that my two side lengths both have to be 14. Let me write in that 14. And I also know, because of my 45, 45, 90 rule, I also know that my hypotenuse is square root of 2 times my leg. So I know that my hypotenuse, which is RP, is equal to the square root of 2 times 14. I'm going to write my 14 in front times the square root of 2. Now, it's a little trickier when I'm not told my lengths of my sides. So in this case, I'm told that my hypotenuse is 24. So let's put it into my equation and see if I can find the value of my leg. I do know that they are equal to each other, but I don't know what they are. So I'm going to put my 24 in for my hypotenuse equals square root of 2 times a leg. If you're more comfortable writing x here, you could just write an x for your variable. Okay, so in order to get the leg's length by itself, I have to divide both sides by the square root of 2. So if it's okay with you, I like my variable to be on the left side. So I'm going to write my leg on this side equals 24 over the square root of 2. So we learned in the last unit that this is not simplified, and I need to rationalize the denominator. Rationalize the denominator. And we learned about this in our Unit 3 packets. So I'm going to multiply the top and the bottom by this radical, the square root of 2, to simplify this. When I multiply fractions, my numerator will be 24 times the square root of 2. My denominator, if it's okay with you, the square root of 2 times the square root of 2 is the square root of 4. I know that's equal to 2. I'm going to just write my 2. And then the 24 and 2 are integers. I can cancel them, and I can get a 12. The square root of 2 and 2 aren't like terms. I can't do anything with them. So the 24 and 2 cancel to 12, and my final answer would be 12 square root of 2. Let's remember what we were finding. I was finding the length of my two legs of my triangle. You could always double check your answer by inserting it back into the problem and then calculating the hypotenuse, which indeed you would get 24. Let's look at that math since we haven't done a lot of radical work. Let's say I want to check this answer. I'm going to insert it in for the value of my leg. So the hypotenuse is equal to the square root of 2 times this 12 rad 2. Okay, so this is really all multiplication. There's 3 terms here. Square root of 2 times 12 times the square root of 2. I'm going to multiply my like terms. Remember, I can multiply my like terms. The square root of 2 and the square root of 2, I can multiply. So I'm going to think of this as 12 times the square root of 4. I know the square root of 4 is 2. So this is 12 times 2, or 24. And that checks out because that is what my hypotenuse was. It does look like I did indeed find the correct length for my side. So let's turn to the last 2 problems we're going to look at on page 445. Can you please pause this video in just a moment and find for me the missing sides? So look carefully at these 2 triangles and see if you can find the missing unlabeled side lengths, and then play the video to see if you found the correct answers. Welcome back. How did you do? This first triangle on the left is generally thought to be an easier problem than the triangle on the right. You don't have to rationalize any denominators. When I plug in the length of my leg, remember this is isosceles, my 45 and 45 degrees are my base angles. This is really half of a square, this triangle. I get my 6 rad 2. However, when I'm given the hypotenuse and I divide my rad 2 over to get the value of my leg, I notice that I have to rationalize my denominator. So my final answer after I simplify is 6 rad 2. If you're having difficulty with this, please bring your questions to our office hours. So in a couple of the homework problems in this unit, it will ask you not only to do this work, but then to find the area of your triangle. I'd like to remind you that the area of a triangle is 1/2 base times height. Also, we've talked earlier this year that my base and height have to be perpendicular distances. They have to be perpendicular to each other. So for example, if I wanted to find the area of this triangle right here, it's really the 6 rad 2 and the 6 rad 2 that would be considered my base and my height. The 12 in this diagram, since it's not one of the sides perpendicular to each other, would not be used in my area formula. So my area of this triangle I've just highlighted in purple would be 1/2 of 6 rad 2 times 6 rad 2. And now what I have here is a lot of multiplication. Look at this, it's really like the 1/2 times the 6 times the square root of 2 times the 6 times the square root of 2. This is not the distribution property. Do not distribute the 1/2, you'll get a wrong answer. So I'm gonna leave the 1/2 for a moment, and I'm gonna look at this and realize the 6 and the 6 are like terms. I can multiply them and get 36. The square root of 2 and the square root of 2 are like terms. I can multiply them and get the square root of 4. And then my 1/2 is still in front. Multiplication's commutative. You can do it in any order. So before I do anything, I am just going to write that the square root of 4 is 2. So now I want to discuss this. In order not to get the right answer, you're not going to multiply the 1/2 times everything or the 2 times everything. You're going to multiply everything only once. It's 1/2 times this, and you can do them in any order. So you really could cancel the 1/2 and the 2 to 1. The answer is 36. Or you could start on the left side and work your way across. 1/2 times 36 is 18. 18 times 2 is 36. So depending on how you do your math, you should get 36 units squared. And there is a couple homework problems in this unit that asks you to find the area after you've used our new 45, 45, 90 rules. Thank you, and I will see you in class.